Okay, so this chapter is all about categorical data analysis and dealing with categorical data. We're going to start off by just doing some kind of simple examples of data manipulation in R. Then we're going to go the second part, the second video, is we'll be looking at the categorical data tests that we did in business stats, but putting those in an R environment. And then finally, we're going to be looking at analyzing transactions using large data sets. So we're going to just kind of cover a range of issues involving categorical data. So what exactly is categorical data? So let me just start off and explain and kind of relate to some of the stuff that you did before. So if we're going to ask what program we're in, so we have a variable called program, and this is the program that you are in. Pretty much everybody in this course is either doing the MS Accounting, the MBA, then we've got some, engineering students, others, so I'll just put graduate others. And then we've got some undergrads. Most are accountants, so I'll just say BS Accounting, and then BS Others. This major, this is an example of a nominal variable. It's discrete. What do I mean by discrete? Well, there's nothing between MS Accounting and MBA. You can't between 1 and 2, it's 1 point, halfway between is 1.5. There's no kind of continuum there. And it's not ordered. So we can't say, for example, I guess we could find an ordering to go with this variables, based on maybe average score in an exam or something. But on their own, the variables are not ordered. I can't say, MS Accounting is top, followed by MBA, graduate others, then BS Accounting and BS others. So that is an ordinal variable. And again, it's anywhere where we have categorical information and it's not ordered. So things like ethnic group, that would be a nominal variable. We could also have an ordinal variable. So maybe we have a variable called satisfaction. And that could be very satisfied, satisfied, maybe we could say neither satisfied or dissatisfied, but let's just say neutral, dissatisfied, or very dissatisfied. So we have that ordering there, and again, we will tend to code these numerically, but they don't have any kind of real numerical value to start off with. I guess we could say, this is 5, 4, 3, 2, 1, but there's no real zero. Again, it's discrete. And the main thing here is we have some ordering between the variables. Now, a lot of people will take in analytics, will actually take this variable as continuous and treat it as a continuous number. You really shouldn't do that, but quite often it works out pretty well. If there's generally an even distance between the categories, then you would maybe say that this is continuous. But generally it's discrete, and we can't guarantee that the distance between categories is even. There may be a bigger difference between neutral and satisfied than between satisfied and very satisfied. So this is an ordinal variable. Now, how do we deal with these in R? Well, we use something called factors. So a factor is basically just a categorical variable, and we define it using the function called factor. And what we would do is, if we have our data, so imagine we have the gender for different employees, we would say, okay, each employee, male, male, female, 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 male, etc. Now, if I just did this, I would actually get a result. We'd have our different variables, the factor they are, and we actually have the levels of the factor. This is very important because R stores these internally as numbers, but it treats them as actual categorical variables. And it does this by assigning levels, saying this variable has two possible values, female and male. Now, if we want our levels in a certain order, we can actually explicitly define them using the levels parameters. We'd say levels, and then we create a list of our levels. So let's do that now. Let's create gender. We could look at gender, and it's exactly as we had just a minute before, but we can see that internally we can convert it to a number. R is actually counting female as 1 and male as 2. So it has this kind of internal system. But this is what R specifically calls a factor variable. Now, here's the second part of our example. Imagine each of these employees, there's some sort of certification. So imagine we're trying to get all our employees analytics certified. And some of them have got no certification, some have got basic, some have got intermediate, and some have advanced. So for each of the employees we gave before, we're going to assign a level of certification. And again, this is an ordinal variable, and if we didn't assign this, it would be done in alphabetical order. So it would be like advanced, basic, intermediate, and none. So we want our levels to be the actual ordering of the data, which goes from none to advanced. And this is our certificate level, or cert level. And there we go again, we have our 11 employees and their certification level. Now, let's just add, we're going to make this an example, so let's just add some more information. Each employee has an ID. This is actually stored as a character string, or just a string. It's just textual information. And if we look at employee ID, and then each employee has a salary, which is a numeric value. Now let's put them all in the data frame. Now, most of the data frames we've used so far, we've actually just used read.csv. But here we use the function data.frame that creates a data frame from all of these. And strings as factors just means when these employees, we're not going to try and make them into factors because they're not factors, it's just string data. So we create our data frame. We're just passing it all of our columns. We can have a look at it. And we can see here that we've got each employee has a gender, has a certification level, and has a salary. We can look at remember the str command tells us about our columns. So again, it says this is the character, this is the factor, this is another factor, and then we have our numeric value. And we can use the summary command. And the summary command will give us a summary of the factors as well as the numeric data. Now, important, the -1, again, this is our way of referencing in data frames, just means we're not including the first column because the employee IDs really can't be summarized. It's just textual information. And then we see here, the salary, we give the quantitative values. We get the minimum, the maximum, the quartiles, and then the mean and the median. And then the gender and certificate level, we actually get the counts of the levels. So there's 5 females and 5 males. And certificate level, we have 3 non, 2 basic, 3 intermediate, and 2 advanced. Now, what can we do with this data? Well, another way of summarizing it, that's using the summary command, is one way is we can put it in a table. So we're going to use the table employee data.gender. And all that does is it creates a little table and telling us we've got 5 females and 5 males. We can do the same for certificate level. And then we have exactly as the summary command. Now, we can actually have what's called a two-way table. And again, this is going back to, remember your business stats? You had a one-way table where you did your one-way chi-squared test, then you had a two-way table, and you did your two-way chi-squared test. So this just summarizes the count by both gender and certificate level. So we could say we have 1 female who has no certification, 2 females who have intermediate certification, and 2 males who have no certification, etc., etc. And if you add these all up, then you're still going to get the 10 employees. We're just summarizing them in 2 directions. Now, that was a nice little simple example, but let's do a summary with a much larger, more complicated data set. So we have here housing data. Let's just have a look what's in housing data. We're actually going to utilize this data set later on for regression. And whoa, lots of variables. This is like all the houses sold in Ames, Iowa, a town in Iowa, over a certain period. And we have lots of information about the house. We have like its lot size, the type of street, the condition, the year it was built, and then the final variable is the sale price. So this data set is mostly a regression. We're trying to use all these features to predict the sale price, but here we're going to categorize it. So let's just have a look. Let's categorize it by one of our categorical variables. And let's just use a table. And let's look at this table. And here, and interestingly, this table command can actually, here we could have loaded in as factors. We're just loading them in as strings at the moment, but it actually works equally well. It will count it as a factor. So we have table, and we see in this data set the majority of our houses are 1 family, 2,400. We have 62 families. We have 100 duplexes, 100 town. And there's 2 different. I think there's a townhouse and executive townhouse. I don't know what the difference is there. But we have 100 townhouses and 233 executive townhouses. Now let's summarize by both neighborhood and building type. So we have all the different neighborhoods, and you can see here this one, maybe Brookdale, is a townhouse neighborhood. This one here, Brookside, this is almost all single-family houses. And we've got other neighborhoods with more duplexes, etc. So we can get a summary by the type of housing stock in the neighborhood. Now let's actually convert this to a data frame. So we're going to put this table we just created into a data frame. And again, to convert, we just use as.dataframe. If we're converting between types in R, we put as dot and the type we want to convert it to. Let's just have a look at this. And then we have basically the neighborhood, the type of housing, and then the frequency. It's all in a data frame. And we can actually, we'll give it some column names, neighborhood and building type. So again, any data frame you can reassign the column name. So we just call columns neighborhood and data type. And let's just have a look at what's in there. Oh, I'm going to do the str. We can see when we converted it to a data frame, it actually automatically converted things into factors for us, because isn't that nice? Then we got the neighborhood, the building type, and then we have the frequency variable. So let's do a ggplot. And let's just have a look at our ggplot command. Here we have, again, we put the data, the format, we put the actual data set, we put in the AES, the variables we're going to use, and then we're going to use something called geomtile. And I'll show you how that works in a minute. And we're also going to use geomtest, which is going to give us our frequencies. And we're actually going to use scale fill gradient, which is going to color our tiles from white to blue, given the frequency. Then we're going to give it a title, and then we're just going to have a few things. We're just going to set the backgrounds to make it look a bit nicer. And there we go. And that's my two-way table. And you see that thing here, the scale fill gradient. We're basically doing it with, we're filling. Remember, ggplot has different scale fill commands depending on the type of data. Here, gradient basically says we're going from low to high. So the highest possible frequency has a blue, the lowest is white, and we go between them. We've got the text, and then we also have the title there. So that's just a nice little table summary of our neighborhood and building type. Now let's use another function. And this is actually going to be quite useful because it's almost getting towards what we're going to do in regression. Here we give, this is what R calls a formula. We have a Y, then we have a squiggle, let's just call it a squiggle, and then we have an X. And we'll use this a lot as we're going forward. But here the Y is a sale price, and we're aggregating it by neighborhood. So here we're just saying we're aggregating sales price by neighborhood. We put our data, and we've got a function we can pass it, which is the mean. So this is basically just saying we want the average sales price by neighborhood. So let's run that. And here we've just summarized, and this aggregate command is used for summaries. We've basically got the average sales price by the neighborhood that we're doing. So we can see here that this must be quite a higher neighborhood. The average price is 330,000. This is a little bit less high end with the average price around 90,000. So this is the aggregation. And now we're going to use this information to plot some more ggplots. Okay, so we're actually now going to plot that data. Now, this is a ggplot, and as you find as we get through the course, ggplots can get very complicated. My best thing to say is just run the ggplot, but then play with it a little bit yourself. You know, just kind of change things, change colors, change things like the ordering. But I'll just go through a few of the major things. So with this data frame we just created, you know, with all the basically has the neighborhood and the sales price. Now we use a command called reorder, which basically means we're just reordering by sales price. And the idea here is we want to show all the neighborhoods in order of sale price. We're gonna use geom column, which is like a bar graph, and we're going to fill it blue. We had to use an external library called scales, and this just allows me to make labels that are dollar formatted. So I wanted to format my labels in dollars. Geom text, which I just give the sale price. Again, it's you build ggplots by adding different features. In this case, we add some text. Nudge Y just means I nudge it a little bit, you know, further away from the bar graph so it's not overlapping. And I've got the labels, the neighborhood and the sales price and the title. And then the most thing is coord flip basically means that I flip it from a bar graph which is on, you know, the Y, you know, with the categories on the x-axis and going up on the y-axis to ones that's the other way around. And this element blank, all that's doing is it's just making sure I have a white background. Okay, so let's run that. because basically I just kind of had a quick check on it for the intermission. Now you notice I said the labels are not overlapping. Well, if you make it wide enough, they're not overlapping. I wasn't lying to you. So again, this is a nice little graph just showing you, just a summary graph, showing you the neighborhoods ordered by sale price. So we aim from this North Ridge down to the Meadow neighborhood. Okay. So we're going to do one more graph. So this time we're going to do it with a two-way table. So we're actually going to aggregate it by neighborhood and building type. So we're going to summarize, we're going to use aggregate on our Y sale price, and our X we have both neighborhood and building type. Mean as before. We could also do sum, which would give us the total value of houses sold. So look what we get, exactly the same as before, but now we have two different categories. Now, what I'm going to do is I'm actually going to create a table from this. So the moment it's kind of in long form, in that there's a row for each combination of our categorical variables. Now, to put it into a table, and make sure you read the notes, because I give like more detailed explanation of how this works in the notes and how you can go backwards and forwards between the two formats. But Xtabs basically converts this into a wider format, a table format. And again, we have the sale price as the Y, but the two categorical variables this time will be as the table. So let's just build the table. And you can see here, we now have it in the table format, or the wide format, where we have our rows of the neighborhood and the columns are the different types of housing. Okay, now this is just to give us a visualization, just to kind of show, so we've got it kind of, we can compare side by side. But when we go to a ggplot, we're actually going to go backwards, and we're going to use the original, because ggplot takes the long format. But this time we're going to use a specific kind of extension to ggplot, which is called the bubble plot, which is in this library ggpubr. Sorry, a balloon plot. And what does the balloon plot do? I'll show you in a second. So this actually recreates the table, but we also have a size by the sale price, and we fill color by the sale price. So we have blues as high sale prices and reds as low sale prices. Now, let's just see how we do this. And interestingly, what I've done is I'm making any neighborhood. So, whoops, sorry. So we have our data set. We fill by the value. And we're also adding an additional scale fill gradient for our coloring. And the low is the red, the midpoint is the white, and the high is the blue. So here we define, as before, we defined two colors, we defined three colors. And here we just, we actually define the midpoint, which is where it's white, as the mean sale price. And then we just give the label. And again, this last little thing, this justification, this is just telling us to get our plot title in the middle. You could play around with this and see what different values do if you don't quite understand what's happening. Okay, guys, so that was just some simple summary functions, how to, use categorical variables in R and how to summarize with categorical variables in R. And the next section will be linking back to your stats 2 and doing some statistics on the categorical variables.